Hello, I'm Nicola Brammer and I work for Science Co. We're a company that manufactures prepreg for the aerospace industry, and I'm a global Six Sigma lead and process engineering expert.
And hello, my name is Sophie Culier. I've been a data scientist and statistician for the company Ipon Innovation. Ipon Innovation is a statistical consulting company based at Toulouse.
And we'd like to present our poster on taking data from different databases and automating the analysis and reporting. So Science Co, like a lot of manufacturing companies, has historically spent a lot of time and money on collecting and storing data. Data is collected both from production equipment via data historians like IP21, Wonderware, and Pi, and also from test equipment that's stored in laboratory management systems such as LIMS. But traditionally, very little thought has been put into how to access and use this data in a meaningful way, let alone be able to combine the inputs into a process, such as raw materials and process settings, and the whys, the key characteristics of the process. Science Co is now working very hard to find ways to extract more value from these data sources. The first step has been to develop add-ins to collate and tidy the data with a minimal amount of effort, with the additional requirements of being able to automatically produce reports from any of our 12 composites manufacturing sites using the standardized methodology for analyzing the data and a consistent format for presenting the information to the customer. In 2023, Science Co engaged Ipon, third-party JMP integrator, to help us write JMP add-ins to assist in this effort. Sophie will now talk about the method she's used to develop the add-ins.
So we have three main objectives. First, we want to streamline the extraction and filtering of data, no matter if it is MES or SQC data. We have developed a ready-to-use toolbox for data manipulation so that even jump beginners can easily manipulate the data they want, that we will present later on. And finally, we want to develop an automate SQC. We want to automate the SQC report generation. So it presents the general workflow of all the different add-ins we have developed, and particularly on the SQC report add-in. So first you will see that in all of the jump add-ins we have developed, in the user interface, the user can very easily he can very easily specify what data you want to extract. For instance, he can specify the period or even add some filters if he wants to add on the filters. He can also the query sent by the user will be sent to the database, so LIMS or MES, it depends. And then we'll get back the data. Sorry, but Nicolas, that was not this report table. No. Maybe we can re-begin.
Yeah.
Well, wait, just a second, Nicolas. Or you can go back to the PowerPoint before we restart. So in all the methods and objectives, I'm not showing anything.
You want to stay on here? Sorry, that's my fault.
Yeah. No issue. Because we can re-begin. On the whole method objective, I don't show anything. I would just show the diagram at the right. So that's it. And I will show after the report table and so at the page 3.
Yeah. Yeah. Okay. Sorry about that.
No problem.
Florence, if we could restart. Sorry.
It's okay. It's okay. I saw that.
Okay.
Will we start the introduction also?
Yeah. We'll have to do everything. Yeah.
Yes. You have to start again. It's okay. It's 4:12. It's okay.
Hopefully not too many times.
Yeah.
Okay. Hello, my name's Nicola Brammer and I work for ScienceCo. We're a manufacturer of carbon fibre prepregs for the automotive and aerospace industry. I'm a global Six Sigma lead and global process engineering expert.
And hello, my name is Sophie Cuvelier. I'm a data scientist and statistician from Hippo Innovation. Hippo Innovation is a statistical consulting company based at Toulouse. I'm also a black belt Lean Six Sigma.
And we're going to present our poster on extracting data from SQC and MES databases. The ScienceCo, like a lot of manufacturing companies, has historically spent a lot of time and money on methods for collecting and storing data. Data is collected from production equipment via data historians such as IP21, Wonderware and Pi, and test data is collected and stored in laboratory information management systems such as LIMS. But traditionally, very little thought has been put into how to access this data and to use it in a meaningful way, let alone to be able to merge information relating to the inputs of a process, such as a raw material, properties and process settings, and the whys, the key customer characteristics. ScienceCo is now working very hard to find ways to extract more value from these data sources. The first step has been to develop add-ins that collate and tidy the data with a minimal amount of effort, with the additional requirement of being able to automatically produce reports from any of our 12 composite manufacturing sites using a standardized methodology for analyzing the data and a consistent format for presenting the information to the customer. In 2023, ScienceCo engaged IPON, a third-party JMP integrator, to write JMP add-ins to assist us in this effort. Sophie's now going to go through the methods of how she developed the add-ins.
So our objectives are mainly to streamline the extraction and filtering of MES and SQC data. We have also developed a ready-to-use toolbox for data manipulation so that even jump beginners can easily do some data manipulation. And finally, we want to automate the statistical quality control report generation. So I will present you in the little diagram at the right the general workflow we are using to develop our add-ins, notably for the last one, that is the generation of SQC reports. First, you will see in the demonstration lantern, but all of our user interface allows the user to easily specify what data you want to extract, for instance, on which period. You can even add very easily filters if you want to see the data of one specific product grade or lot or whatever you want to filter on. Then the add-in, once it's finished, the add-in will translate the user query into a real SQL query on the database. So it can be LIMS or MES database. We are doing both of them. Finally, the add-in will get back the data from the database. And from this, we can build different outputs depending on the add-in and the needs. For instance, in the context of the SQC report generation add-in, one of the key outputs is the PowerPoint, which is the SQC reports. We will show again later on. But the issue with that is that the PowerPoint generated by JMP is not, well, very pretty at the start. So on top of GSL, we are using other scripts like VBS or Python to format a bit the PowerPoint we obtain. For instance, if we want to align images, tables, or change the text style and so on. So this is a formatting step. And last step, which is very, very important in our add-in, is the reviewing step, because the user will get back all the output from the analysis. But at any moment, you will see in our add-in, it can review the output. For instance, if you want to modify data, if you want to exclude some rows that need to be excluded in the data or so on, you can do it very easily. And with just one button, we generate the whole report instead of doing all the change manually. So this is a very key point.
So we're going to demonstrate some of the user interfaces. So I will quickly show you an example of the user interface. The user interfaces allow the user to select the parameters they want to only extract the information that they want. And the user interfaces for each of the different queries, whether it's process data or laboratory information management system data all look very similar. So that means that the training is more easily done with our different operators, particularly operators that don't use JMP a lot. So we've tried to standardize the output that they see. Once they've selected the settings that they want, they can easily save the report with all the parameter settings and then reload them up at a future date. And those parameter settings are saved in a data table that looks like this. You can see that there's tags in here, and these tags include both continuous data, such as machine speeds and temperatures, but also contextual data, such as batch numbers, recipe numbers. The output table from running the script also contains a number of subscripts that help us to examine the data or to add additional tags or rows of data at a later date. So Sophie is now going to talk about the automated PowerPoint presentation in particular.
For this add-in, first thing is we need, so we are generating reports. To generate reports, we first need to define what is in the reports. So the user can at any time, in the add-in, we have a table that we call reports config that is generated by the add-in, but by default it is empty. And in this table, the user will manually enter the information of the different reports he wants to be able to run with the add-in, this table. So this table will be read later on by the add-in. So for instance, here it is a table. All the columns are already put there by the add-in. The user just have to fill in the column information. For instance, the location. The location will be from which server we're extracting data. Then we have 3 columns like product grade and spec detail name and matter description. These are filters we are going to apply. For instance, here in this report, we are only going to extract this product grade, this spec detail name, and this material description. So these are filters we will add in the query. Of course, this is a need of CN scope, but you can adjust the idea on your company and your needs. Then we have 2 columns are about the period value and period unit. This is how much data you want to extract in this report. Typically, here we are going to extract 24 months of data in this report. Then we have frequency value and frequency unit. You will see later on, but there is a notion of frequency in the sense that these reports will be generated every 13 weeks, and you can adjust the frequency. We have other columns we are using in the context of our needs. So you can put anything you want in the context of your company. So once that the user have added or modified the reports he wants to generate, he can run the add-in. And you will see that in the add-in user interface, you will see the report table. So in the user interface, the user will see the same report table. He can then select one or several reports to be run. And for each report run, there is in total 6 outputs that you can see here. First, we have 5 jump tables for every report. The main one, the most important one would be the row table. So if we open the row table, it's kind of, like we say, very alike as the other ones, because we are trying to standardize every output in the different add-ins so that the user is not lost in each add-ins. So it's just raw data from the database. You can see again at the left table variables that we would call the information of the report, such as the period of extract and the filters. You can see again the additional tools script that is very useful if the user wants to do some basic data manipulation, even if it is the jump beginners, like color coding or or even showing the limit table or control charts very easily. So this is a row table. It can interact, of course, with this row table. We have also the unstack table. Well, basically, the unstack table is actually the same as the row table, but instead of having the parameters in rows, we have them in columns, which is more practical if we want to use some control charts. And also one table we could show is a limits table. In this limits table, we are just the spec and control limits for each parameters. So it is already formatted by the IDIN. The user don't need to search for this limit in the table. And of course, the most important output for this IDIN is the SQC report. So this is a PowerPoint. What we will show here is the very raw result from the IDIN. We haven't touched anything or modified anything in the PowerPoint. It's what the IDIN gives. So of course, here we have the Science Code template behind, but you could adjust this and use your company template. So first here you have the cover page where the information are already filling with the one from the report automatically. So user don't have to do anything. Then in page 3, for instance, we have the parameters, so recall of the parameters and the limit table that you could have also in the output gen table. We have also the list of batches and the appearance date. We have the part number and description. And for each parameter, we have plotted the control charts with color-coded by the parent lot and with the spec limits and control limits. At the very end, we have also the capability, summary of capability for each of our parameter. So at this point, the user just have to fill in the conclusion and recommendation page. Everything was already automated by the IDIN, doesn't need to do anything. But as I told you, in the IDIN, he has an option of previewing. So in the row table I showed you earlier, the user could modify the data and just with one button, we generate the PowerPoint by taking into account the modification he has done. Okay, so this was all for the on-demand mode. Then, of course, when we saw that it was very used, the on-demand mode, we have tried to automate this on servers. So if we look at the page 3 of the presentation, what we have done is that, so this is the left bottom part. We have a jump script. Well, Scienceco has different Windows servers around the world with different data and different reports that need to be generated. On each of these servers, we have, using a scheduled task, we have a plain jump script to be run on each day. This report will look at the reports on each server, check which reports need to be generated using the frequency. For instance, if we see that some report need to be generated every 13 weeks and it has been 14 weeks, it has not been updated, it will generate it. So this is the ID. Once that the report have been generated, there is an email notification to the quality engineers, well, the engineers, to warn them that some report was generated and he can check it and review it if needed. So to show you, this is the output of the email. It looks like this. So you see, it is sent from a generic email address, and it will in the content of this email is basically which report has been generated, if it has been generated successfully or not. For instance, here we see that the report 5 has been generated, and we have the location of the output. So here it is on shared drive that the output of the report are put. Of course, the user needs to have access to the shared drive, or otherwise he cannot access to it. And in this location, you would find the 5 gem tables and PowerPoint I showed you earlier. And there is also attached the log in case there is an error in the generation of the report. So this was the raw idea for SQC automated report add-in.
So the aim of this add-ins has been to reduce the data gathering and tidying burden on the quality and production engineers to ensure that we have a standard methodology for reviewing the data and to produce consistent customer outputs from all our sites, while still allowing us to have full access to the data set for any additional problem solving or more in-depth exploratory data analysis. The feedback from our users has been extremely positive, with many engineers saying that it's reduced the burden on them from between half an hour to 8 hours per query, and they're using these tools daily. The greater the level of instrumentation on process equipment and the more recipe information that's available, the greater rewards, because this allows data tables for inputs and outputs to be easily combined. This work is built on initial add-ins that were developed by the Science Code Data Analytics Group for extracting process data, but has been taken to another level by the ability to combine both continuous and contextual information in the same database. The original add-ins developed by the Science Code Data Analytics Group can be found on the JMP community website. Thank you, and we hope you've enjoyed our presentation.
Thank you.